So here the first question is the element of a 3 by 3 matrix, right? The element of a 3 by 3 matrix, right? Matrix A are the product of its row and column indices. Aij is equal to I into j. So A11 is 1 into 1, A12 is 1 into 2, A13 is 1 into 3. So I can create a 3 by 3 matrix like this. That is say A is our matrix, that is A11, A12, A13, then A21, A22, A23, then next is A31, A32, A33, right? So this is our 3 by 3 matrix, right? But it is given that this matrix is equal to product of I and j, that is 1 into 1, 1, 1 into 2, 2, 1 into 3, 3, right? 2 into 1, 2, 2 into 2, 4. Now 2 into 3, that is 6, right? Now 3 into 1, 3. Now 3 into 2, again 6, right? 3 into 3, 9, right? Now what is the eigenvalue of this? So we studied some tricks. See, finding lambda 1 plus lambda 2 plus lambda 3. See, here one problem is, see, suppose you find lambda 1 plus lambda 2 plus lambda 3, right? What is you get? 1 plus 4 plus 9. 9 plus 4 is 13, right? 13 plus 1, 14. Okay, product of eigenvalues, determinant, right? So here this row is product of 2 into this row, right? 1 into 2, 1 into 3, 3, 2 into 3, 6, 3 into 3, 9. So here you can see R3 is equal to 3R1, right? If one row is the constant multiple of other row, definitely determinant is here. Now the problem is, look here, 7 plus 7, 14. This condition satisfied. 7 into 7 into 0, 0. So this also satisfied. But look here, 14 plus 0 plus 0 what? 14. And the product of this is what? 14 into 0 into 0, 0. So two options satisfying, right? So there we studied one trick. If one row is the constant multiple of others, what we studied the rule, two eigenvalues are 0 and the third eigenvalue is the sum of the diagonals. 1 plus 4 plus 9 what? That is 14. So this is the answer.